Hello and welcome everyone to today's webinar on developing FT and NFT apps using Oracle Blockchain platform tokenization. My name is Tara Van Cleve and I'm a marketing event manager for the developer initiative here at Oracle. We're excited to show you how Oracle Blockchain platform enables low-code implementation of FTs and NFTs and how customers are using these in their rewards programs, supply chain tracking, Web3 ecosystems, and NFT marketplaces. If you have any questions during the webcast, please ask them in the Slack channel or in the Zoom chat, and we'll answer them throughout the session as well as at the end after the demo in a live Q&A. The link to join the Slack is bit.ly/odevrel_Slack, and once you're in, you'll land in the general channel. From there, you can search for #webinar Oracle Blockchain to reach our dedicated space for Q&A today. Today's webcast will be presented by Mark Rokmilovic, Senior Director, Blockchain Product Management, Bala Velanki, Director, Blockchain Product Management, and Gaurav Sarkar, Senior Manager, Blockchain Product Management. So without further ado, I will hand it over to Mark.
We have an exciting session for you today. There is a lot of content. We are going to cover an introduction to the blockchain tokenization, provide you an overview of tokenization in general, and then specifically we'll talk about the built-in support for fungible tokens and NFTs in Oracle Blockchain platform. We'll share some custom examples and use cases, and then talk a little bit about how we can help developers and customers with their blockchain journey, things that Oracle does that make it easier for you to get started. So let's get going. First of all, just start with some basics, right? For those of you who are not intimately familiar with tokenization, just a brief introduction. What is it and why it matters for the enterprises? There are three fundamental reasons here, right? Tokens fundamentally are a way of representing assets in a digital form that can be self-describing. Namely, they include things like attributes, rights, obligations related to the asset, and any relevant rules on how to handle that particular asset transitions, state transitions, ownership transitions, custodial transitions, and other things like that. When tokens are based on a blockchain ledger, you now have ability to use them in multi-party processes so that you can leverage the trusted, tamper-resistant, immutable record that the blockchain provides. This essentially enables, asset exchanges, trades, and exchange of tokens across multiple individuals, multiple organizations, and so on, which you could not do in a trusted manner without the blockchain ledger, right? You have to go through intermediaries and so on. If you think about how digital assets are generally traded prior to blockchain capabilities. And when you then couple smart contracts on top of that, smart contracts provide programmability to the tokens, meaning that you have flexible validation rules. You could define application-specific behaviors associated with state transitions. All of that is automated and codified in a way that's very easy and transparent to verify and be able to apply across various situations. If you're interested in learning more about the impact for enterprises, there is a Forrester report that I would recommend called Invent the Future with Asset Tokenization. But fundamentally, what we see from business customers that are leveraging Oracle technology is tokenization can help affect the bottom line, namely create process efficiencies, reduce fraud, as well as top line, namely their revenue, by creating new multi-party processes, supporting new revenue streams and new business models. The benefits from an enterprise perspective from many companies we have worked with the following. So you can represent asset transfer, ownership, or usage rights. Doesn't have to be full ownership, could be licensing, any kind of usage rights to the asset in a trusted, immutable manner in a real-time environment without relying on complex API-driven point-to-point integrations. You can verify the ownership history without relying on intermediaries involved. You can support fractional ownership, which helps to increase liquidity. You can track digital assets that are natively born in the digital world, or you can use digital twins as a representation of a physical asset. And that could be done across enterprise business units, in B2B transactions, and even in engagements in the B2C world. There is a great report from OECD that distinguishes between pre-existing real assets, which can exist both in the physical world and on chain, and not only financial assets. This is an example here, but in theory, any kind of physical asset. A car could be represented as a token, for example, right? Piece of machinery, equipment, shipping package, anything like that. Or tokens native to the blockchain, which are strictly digital assets created in the digital environment and then traded as, if you will, virtual assets of some sort. All of that enables various enterprise systems to control what level of access is available and what kind of operations can be performed on the asset based on of that embedded information, the state, the attributes, the actor requesting the change, and all of that can be validated through the codified rules and then acted upon. You can allow that particular request or you can reject it, etc., based on all of that information. So tokenization, of course, something that came to our attention with Bitcoin and cryptocurrency for a number of years. Ethereum, of course, pioneered more programmable tokens with smart contracts. ERC20 for fungible tokens, 721 for non-fungible. We now have additional models such as ERC1155, which is a standard that combines fungible and non-fungible tokens in a single smart contract. There is another one called ERC1400 for specific tokenization of securities, which has a little bit more of a governance and auditability around it. And there is new networks, of course, we know about, Flow for digital art, collectibles, and things like that. But in an enterprise context, we're beginning to see use of those capabilities as well. So there is emerging use cases both with fungible tokens and non-fungible tokens. On the fungible side of the ledger, rewards programs, loyalty programs, royalty tracking, payments, particularly cross-border payments or funds transfers. And one of the more resonant use cases these days is digital currency and bank-backed digital currency, not cryptocurrency, and CBDC, central bank digital currency, which is essentially creating tokenized currency backed by central bank, auditable, regulatable, etc. And we're actually beginning to see some engagements in that space as well across the world. In non-fungible tokens, you can see VIP rewards, for example, in loyalty systems. When you reach certain level in the loyalty system, you might be awarded certain specific, unique NFTs that provide access to certain privileges or access to certain events, maybe, and so on. We're also beginning to see it in regulated production supply chains, where you want to be able to trace unique components. It could be aerospace manufacturing, it could be pharmaceuticals or other things. Electric vehicle battery passports, when batteries are going to be going through the entire life cycle beyond the useful life in a car, repurposing and recycling, and so on. And I'll share some examples. In global logistics, electronic bill of lading, which is a negotiable document pertaining to particular shipment, changes owners and custodians as the shipment goes through. That's a great example of using NFT in a logistics space. And other supply chain examples, such as supplier certifications, qualifications, and so on. So all of this are very interesting and active engagements that we see in an enterprise environment, in an enterprise context of using both fungible and non-fungible tokens. Now, Oracle's approach to tokenization begins with the fact that our platform, our blockchain platform, is built on Hyperledger Fabric infrastructure. This is the Linux Foundation open source project that's been around for 6-7 years, I think, at least, which we've joined in 2017, and we released our first blockchain platform version in 2018. So it's been in the market for over 4 years now, pretty mature. However, it does not have built-in token support, unlike Ethereum, let's say, or Polygon or some of the others. So that does not prevent people from creating application chain code that mimics, if you will, the tokenization capabilities of ERC20, ERC721, and so on. And when we've seen enough of those, we decided that it was time to actually provide standardized tokenization chain code available as building blocks so that people don't have to reinvent it all the time. So we have this low-code development tool called Blockchain App Builder, and Grav is going to go through some details on that. And it's able to generate all the necessary chain code from a template or specification. So we leverage standard specifications such as token taxonomy framework, which initially came out of the Ethereum Enterprise Alliance and now part of IWA open source, and also ERC specifications from Ethereum to create meta models, and then templates based on those meta models where we can define token types, their properties, behaviors, add custom properties, custom methods, and so on. And we've also optimized the transaction validation logic in Hyperledger Fabric to provide much higher throughput that was possible beforehand. And this is now something that's been available in our blockchain platform, starting with fungible tokens, which were released last year. Earlier this year, we released support for NFTs based on ERC 721. We are working on adding support for ERC 1155 capabilities, which will be available before the end of the year as well. And so there is more and more work that we're investing in supporting a variety of tokenization standards and capabilities in Oracle Blockchain Platform. Token taxonomy framework was an interesting model because it provided this very generic approach that allowed you to create different classes and then instances based on those classes by defining essentially what became a formula for what different types of tokens mean and what behaviors they support. So you specify the base type, you then add specific behaviors or groups of behaviors, and then property sets as well. And those behaviors could be things like whether it's transferable or non-transferable, divisible or whole, singleton. This is what distinguishes an NFT token, for example, right? It's actually of type singleton. Mintable, meaning you can create new tokens of that class. There is role-based security built in as well, and ability to burn or destroy tokens as well. And so we have created templates that essentially allow us to support these capabilities directly in Oracle Blockchain Platform. So let's talk a little bit about the platform and how we support those tokens. Just as a quick introduction, I mentioned we are based in Hyperledger Fabric from Hyperledger Foundation, which is part of the Linux Foundation, that umbrella. The blockchain platforms that you can create either in Oracle Cloud, or we also have an enterprise edition software appliance you can deploy on premises. Consists of Hyperledger Fabric nodes. So you have the peer nodes, which have copies of the ledger, and you have smart contracts ability, so you can run smart contracts on those peer nodes. You have an ordering service nodes, which is a separate type of nodes that take as input transactions that have been executed through the smart contracts and the outputs, read-write sets signed by the peers, and then group them and sequence them into blocks. And those blocks are then sent back to the peer nodes to be validated and added to the ledger, one transaction at a time. So this is the fundamental capability in Hyperledger Fabric. And the reason peer nodes and ordering nodes are separated out is that you can scale them independently, and you can assign them to different participants independently, and so on. There's also membership service. This is one of the key characteristics of a permissioned blockchain. Everybody is a legal entity known member, issued a certificate, X509 PKI certificate, and you could have enrollments and multiple users under that certificate enrollment and so on. But fundamentally, everything is signed using PKI technology, and all of those certificates have been associated with a particular identity. So there is built-in identity management integration here. Now, we have added to the community edition of Hyperledger Fabric a lot of Oracle enhancements, a lot of operations and management tooling, both the web UI console makes it much easier to create and manage and operate and troubleshoot, as well as DevOps APIs, a very rich set of REST APIs to do all of the operations and administration changes, configurations through the REST APIs. We have added an API gateway that provides orchestration capability that allow us to run smart contracts, invoke them through REST APIs, synchronous and asynchronous, subscribe to events and get notifications and callbacks with reliable delivery, and provide orchestration across multiple chains and multiple other resources using two-phase commit, which I'll touch on as well. All of this is supported by underlying infrastructure, pre-assembled container management using Docker Swarm, high availability deployments out of the box. You could deploy across multiple cloud data centers in the region for high availability, dynamic scaling. You can add resources and move them around, built-in identity management, zero downtime patching. And we've also focused a lot on confidentiality and security auditability, which are very critical in business applications. Fine-grained access controls, so chain code can determine if somebody is allowed to perform a particular operation. On-chain access control list, configuration audit log on-chain as well. So every configuration change is actually recorded as a blockchain transaction for immutability and can be retrieved through event subscription. Block integrity verification, you could walk through for auditing purposes and recalculate the integrity of all of the blocks and so on. We've also created capabilities to integrate this variety of applications out there in the business environment the blockchain is not going to sit there standalone. It's going to be integrated with SaaS or on-premise applications with the Oracle third parties, and we see a lot of interest in integrating it with supply chain management, ERP applications, HCM, human capital management, HR onboarding kind of use cases, whereas on-premises applications. And so we provide REST APIs. We provide strong integration adapters for particular applications in Oracle Cloud, as well as we support open source Hyperledger Fabric client SDKs. On the right-hand side, I talked about our Enterprise Edition, which is also the same platform, but available outside of Oracle Cloud as a VM, as well as interoperability with other non-Oracle Hyperledger Fabric nodes, which allow you to create networks across multiple clouds. In fact, we have multi-cloud deployments today in production using multiple vendors' Fabric nodes. And then also integration to stream the ledger updates as they come in to Oracle database, where you can apply analytics, visualizations, machine learning, and the like to enrich your experience and the user experience based on the blockchain ledger data. You can visit oracle.com/blockchain for more information. On the platforms, there is a great ebook there that we publish that goes through some of the key advantages, as well as many industry-specific vertical use cases that we have worked with over the last 4.5 years. It's a very easy platform to get started with. If you have already an Oracle Cloud account, you can go into that account, use your drop-down menu here on the top left, drop into developer services, and then you'll find blockchain platform on this list. When you click on blockchain platform, it brings up a control pane where you can easily create blockchain platforms. There is a single page wizard. You specify a couple parameters here and then click create. And this will marshal all of the resources. It will actually kick off a provisioning task, takes 10-15 minutes, and then everything that you need is ready to go. All of the infrastructure resources necessary, the Hyperledger Fabric nodes with up to 16 peer nodes available. You can dynamically scale. I think we start with smaller number when we do initial provisioning, but you can dynamically scale through this dynamic scale-up wizard to up to 16 peer nodes. For instance, all of API gateways that I mentioned, management services, operations console, all of those things are readily available. And when you drop into the operations console, you actually now have ability to look at the dashboard of your peers, channels, etc. You can go into network dashboard, individual nodes, channels. You could subnet the network across multiple ledgers, isolated with different members authorized to participate, and then the chain codes of smart contracts. There is full lifecycle management capability for smart contracts through the wizard or the blockchain app builder, which you can download from the developer tools tab as well. And a lot of monitoring, troubleshooting, topology views, for example, peer nodes across different channels, or ledger browsers that allows you to see the blocks actually on the ledger and then drop down into a block to see specific transactions within that block, and many other things. Now, as I said, all of that investment we have been doing over the last few years helps tremendously to create a production-ready blockchain platform right off the bat. You don't have to invest in hardening or making it enterprise-ready, which takes a lot of skill and a lot of time. It's ready pretty much from deployment perspective, integration with back office systems, security perspective, operations management, and easy to evolve and add new nodes. We have wizards to help you expand it and expand new members, new nodes, and of course, as I mentioned, interoperability to work with other clouds as well beyond the Oracle Cloud. But building blockchain applications requires additional set of skills on top of this infrastructure. So we've done two things. First of all, we created a growing portfolio of partners that create industry solutions. And this is something that's going to allow people to start using the platform right away with those ISV or SI solutions. And then we've created this custom tool called low-code. It's called Blockchain App Builder. So it's a low-code development tool that can automatically generate smart contracts from templates. You can basically use basic regular English descriptions to create a template for the data you want to manage on a blockchain, whether it's tokens or other kinds of data. And then we will generate automatically all of the chain code methods necessary for basic crowd operations, or if it's a token type, for the token lifecycle operations. So this tokenization is pretty much built in. You can go from provisioning environment to downloading the blockchain app builder to using built-in templates or tailoring them if you want, and then generating, deploying chain code in a matter of minutes, half an hour perhaps, and so on, and you're ready to go. And we'll ask Gaurav to talk through the capabilities in the blockchain app builder. Gaurav?
Thanks a lot, Mark. So for the blockchain app builder, what Mark was mentioning, it's a low-code development tool. If you look at developing any application using blockchain and the blockchain on Hyperledger Fabric, the chain code is a very essential component where your business logic resides. And blockchain app builder would help you to develop that chain code automatically. You'll be able to test it. You'll be able to deploy it on either on the local environment or on the Oracle Blockchain Cloud Services as well. So what Blockchain App Builder comes up with, it comes up with two different flavors. One is a Visual Studio Code where you'd be able to just deploy the chain code, create the chain code automatically, customize the chain code, and test it completely. We also have a lightweight command line interface to power users for the CI/CD automation. Now, if you look at the blockchain app builder, the first step is to scaffold the chain code project using a spec file, which Mark was mentioning. Through the spec file, you can just define the English-like words, and in the backend, it will create the chain code automatically. You'll be able to have the complete support for the chain code lifecycle operations, starting from the packaging, installing, instantiating, and the upgrading of it. And very, very important part over here is that you can deploy it very quickly. You can test it very, very easily. So you can either do it on the local or on the Oracle Blockchain Cloud Services. But from the smart contract or from the chain code perspective, it will help you to generate in two different languages. So we have two different language support for now, which is the TypeScript and the Golang. And this chain code generates a lot of CRUD methods, along with you can also have the custom methods available there. Next slide, please. So with the help of Blockchain App Builder, what we did, we are creating or developing the chain codes for the token support. So in the tokenization part, so we have a token taxonomy framework standard, which we have adopted for the fungible token, and the ERC standard. So we have the ERC 721, which supports the non-fungible token. So what we do is that we have this specification file where we define the tokens and the token assets and their behaviors. Whether this token can be minted, whether this token can be transferred, burned, so on and so forth. So we define all this, and along with that, we also define the custom properties. So for a specific token, if you'd like a custom property like the exchange rate or a specific SKU you'd like to define, you can also do that. This template supports you the account-based fungible token or the non-fungible tokens. So there are two different token models there. Either it's a account-based or the UTXO-based model. So we have the account-based model, which helps you to scale your application very fast. And what it does is that it has a complete set of lifecycle support for the tokens. So starting from the initializing the token, creating the accounts, adding the roles, so which can be done by the admin, and then the operations which can be done by the different users, like minting, transferring, escrow kind of a mechanism, or the burning of the tokens. Next slide, please. So in the underlying layer, what we have when the code is generated automatically, there are three essential components which comes along with this code generation. One is a token SDK. So you can use this token SDKs. So these token SDKs are based on the different behaviors that we have set in the specification file, like the mintable, transferable, burnable, so on and so forth. And what you can do is that you can use those SDKs and you can develop your custom methods. So you can really leverage those SDKs to build your custom method and add the different business logic. This SDKs support the ERC 721 framework as well for the NFTs. And what it also does is that it also supports you the account-based model. But what we have done is on top of the SDK, we have also created the wrapper functions, which takes the inputs for the organization ID and the and the user ID. So if you'd like to integrate with the IDCS systems, it is very, very easy. And what we have done is that we have provided out of the box 30 plus method support in the token wrapper function, with which you can develop a complete application very, very fast. So we have used a very minimal number of methods for developing an application, but you can leverage the very rich number of methods that we have provided. And the third very important part is the built-in security. So the security, we have the role-based security is given during the token initialization and the account creation part. So we have the roles support like minter, burner, notary. So notary is basically the escrow kind of a mechanism that we have provided. So you can provide the different roles, and based on that role, the method can be accessed. So overall, it has the complete availability of multiple different methods, and these methods can be rightly used by the REST API. So if you'd like to use it in your application very fast, so you can use the already available REST APIs for it. You can have the cross chain code invocations with the help of the method that we have provided over here. And the very important part here is that you can build any kind of complex application just with the help of the methods that is auto-generated. Okay. Next slide, please. Yeah. So just I would like to give here one very important part is that how it exactly works. So if you see over here that it first starts with a specification file, which is a declarative specification file, which this app builder takes it as an input. And what it does is it generates the code automatically based on that specification file. Once this code is generated, you can do any kind of customization. So you can add any custom methods on top of it to ensure that your business logic is included over there. And once you are done with your customization, then you can deploy it. So either you can deploy it on the local environment, which comes along with the app builder, or you can do it on the OBPCS or the OBP environment, which is a remote environment. And once you deploy it, you can start testing the chain code or debugging the chain code. Which is very important over here is that when you deploy the chain code on the OBPCS environment, it can be automatically used as a REST API. So you can invoke that specific REST APIs in your application to really develop it faster. Overall, what it does is that each and every segment has its own value propositions here. So it can generate the chain code very quickly, automatically. You can do any kind of customization on top of it. You can have the local environment and the remote environment support. And overall, you can do your testing and debugging very quickly. So you can complete the entire applications very fast and very quickly. That's it from my side. Over to you, Mark.
All right, thanks, Gaurav. Appreciate it. So as you see, a lot of benefits, obviously, from using blockchain app builder as a low-code tool. And what you can do then, once you've downloaded, installed the app builder and started using it, you can continue to maintain the chain codes that are generated. We have the capability that allows you, once it's been deployed, if you go back to the template, you can touch up the template, make some changes. Maybe you need to add some new property or something. It will automatically then, if appropriate configuration is set, it will automatically regenerate and redeploy the chain code. So this entire life cycle will be replayed, if you will, based on any changes you make in the template, if you configure it, to allow you to do that. As you have seen here, we have been trying to leverage the technologies that's coming from, public blockchains, but also extend it and adapt it to make it useful for business customers. And that means, being able to do things that standard ERC-721 NFT, for example, cannot. First of all, the benefits on the permission blockchain network, there is no gas fees. So there is fixed platform costs based on the scale, how many cores or CPUs you're using, storage, etc. But once that's fixed, you're not paying per transaction fees. A lot less energy consumption. There is estimates about 1 millionth of energy consumption compared to, let's say in the Bitcoin or Ethereum, and of course a lot less emissions, and so on. Much higher performance to thousands of transactions per second with, a second or sub-second latency. And because it's a permission blockchain and everybody is identified, as you would want to see in the business application, there is confidentiality and privacy capabilities, including GDPR compliance and other things like that. Our account-based system supports built-in custodial wallet capability, which is much easier to set up for many users who don't have crypto wallets. They don't need to remember, secure their private keys. If you need to recover account, you can easily do that, and so on. So for vast majority of business users, this custodial wallet implementation is going to be much more palatable. We also make our NFTs much more dynamic in two ways. First, it allows a minter to extend the metadata before they transfer the NFT. So you might have minted the NFT, but before it's actually sold or transferred, you might have some updates or some things, some properties, etc. So the metadata can be updated. Second thing we do is there is a section for custom properties, which any current owner of an NFT can update. So you could add properties like, maybe current minimum price, whether it's sellable, anything associated with the business object it represents, and anything like that. If you're an owner of an NFT, you can update those custom properties. The core metadata remains immutable at that point, of course, and so it represents a unique object. But objects evolve, right? Objects are not static. It's not like a piece of art that you sold once and that's it, or maybe business objects tend to be dynamic. Built-in security, which is so important in business applications, we already talked about all of that. Ability to burn NFT tokens, which you cannot quite do with ERC 721, particularly useful if you want to transfer it from the Oracle blockchain platform to another ledger, maybe for more liquid, marketplace or other requirements, cross-ledger requirements, etc. You can burn it on Oracle blockchain and then use all of the transaction history, put it in the metadata, and remint it on another platform. Built-in REST API gateways that provides all of the orchestration necessary, so you could easily start by creating user experience or business process management clients for full lifecycle. You don't need any separate gateways or anything like that. And we've recently added support for atomic cross-chain updates and asset exchanges using two-phase commit, which is going to ensure that you have fully secure and very robust environment where transactions happen on both chains either together atomically or they roll back atomically. That's very important. And of course, we wanted to provide capability to embed NFTs into more complex applications, right? We're talking about business environments. So the templates are tailorable. The code is adaptable because we provide everything that we generate in source code. And this library of 30+ wrapper functions is customizable and extensible as well. So you could then start building much more complex applications on this baseline. Now, some of the use cases we have seen since we have introduced this capability in Oracle Blockchain platform across both B2C companies, retailer experiences, VIP rewards and loyalty systems, fan engagement, in-game and metaverse kind of tokens, traceability of unique luxury goods, which is something that's been already done on blockchain platform, but now extended to use NFTs. In a set of B2B companies, we're also beginning to see adoption of this. So there is electronic bill of lading applications, for example, which is a negotiable document in logistics, often changes hands as the goods shipment is moving through freight forwarders and different shipping companies and so on. Data marketplaces and IP marketplaces, uniquely identified components in certain distribution chains, electric vehicle battery traceability through the life cycle as it goes beyond the useful life of a car into repurposing, recycling, and so on. Now, you might say, well, some of this have been done in public blockchains. Why use permission blockchain for this? Well, the reasons that customers are coming and saying that they want to use a permission blockchain are the following. They want to reduce the risk of provenance fraud. There is a lot of fraud going on open marketplaces, right? So IP ownership authentication is very important, and doing that in a managed permission blockchain is much easier. They want to maintain stronger branding and content controls. They don't want to be associated with whatever else an open marketplace might put on that marketplace, right? They want more secure integration with the internal systems, security compliance, privacy compliance. They want to be able to integrate fiat payments rather than crypto wallets, so crypto wallets can be used as well. And ultimately, they want an enterprise-grade, production-ready environment that provides high levels of availability, consistent performance, SLA commitments, all of the things that enterprise systems can provide, right? And this is something that is going to be very important for many business applications. Now, we have actually created a reference architecture in Oracle Cloud Infrastructures. Here's the link. You can come and see this reference architecture for an NFT marketplace built using this technology, starting with Oracle Blockchain Platform, our content management, which is where you're going to have the actual content data related to NFT, and then Visual Builder, which is a low-code environment to create your user experience, right? So you can build your NFT marketplace. You can integrate it with our mobile hub. You can integrate it with our CX Commerce for payment gateways and e-commerce capabilities, database and analytics for dashboards, customer on-premise systems as well can be integrated. And so this is, if you will, a solution playbook that you can go and work through to create your own NFT marketplace. But in case you want more of a turnkey solution where you don't want to be building some of this, we do have partners that provide turnkey capabilities around the world and can quickly and easily provide an NFT marketplace based on this set of technologies for your kind of a, if you will, bespoke, or sometimes people use the term walled garden kind of environment. Now, I talked earlier about, ability to interchange things between the permission blockchain and open blockchains. So we are introducing, and this is something that's coming up before the end of the year, not currently in the current release, but the ones that will be released in December, ability to interoperate with Ethereum. We have integrated in our API gateway guest client, which is a Go Ethereum client, and two-phase commit capabilities that allow us to do operations that provide both safety and liveness properties. So this, very storied two-phase commit transaction orchestration protocols that's been in financial industry and many other environments for generations, really, in financial systems in particular. And what this allows you to do essentially is to do a prepare phase on the Oracle blockchain side, where it may be token or maybe even non-token related operation. And then we will use the Ethereum client to do an operation and invoke smart contract on an EVM, here Ethereum or any kind of EVM compatible blockchain. And we'll verify it to make sure that the transaction, in fact, met verification requirements, how many blocks deep or how many seconds to wait, et cetera, et cetera. And then we'll come back and step 3 will commit what we've done here in the prepare phase to an actual commit transaction in the blockchain ledger. And so this allows us to combine two-phase commit capabilities in Oracle blockchain with what's called last resource committed optimization for Ethereum, which does not have built-in two-phase commit. And so you now have ability to do this atomically. So that if you're doing, for example, an example here, atomic asset exchange, right? So you want to prep and mint NFT on Oracle blockchain. And then when somebody buys it, you want to transfer it out to Ethereum. You could do this atomically in a way that it only exists either in one place or the other place, and you are not using any bridging solutions, which are so vulnerable to protect, to attacks and things like that. Or let's say you want to transact some assets here, but you want to pay for them using ETH, right? So you can do that. You can combine an asset-related transfer request with an ETH payment on Ethereum side into single atomic transaction, right? And they either both happen together or they roll back together. And so this is a capability that's going to make it much easier to interoperate with public chains. And again, it's something that's coming out before the end of the year in December. We have a lot of plans to continue to expand our Web3 capabilities. I think there was a question earlier. So we are, in fact, adding ERC 1155 support, fractional NFT, hierarchical NFTs. There is a lot of business applications that we're beginning to see interested in that. Non-custodial wallet support. So we already have custodial wallets available built in, but for native OBP tokens, will provide support for non-custodial wallets. We already support Web3 APIs, and we can run Solidity, I should mention Solidity chain codes by providing an EVM emulation on top of Oracle blockchain today. You can deploy Solidity chain codes out of the box using Remix, for example, or using Web3 JSON RPCs, and this is available today. And various exchange methods, which I talked about, either within OBP or across OBP and Ethereum, for example. Additional decentralization areas, cross-chain interoperability with other chains using Hyperledger Cactus, which is a new project under Hyperledger umbrella. Decentralized identity support. We're working with some universities on bringing decentralized identity capabilities to Oracle Blockchain. Decentralized governance, connections to off-chain computing oracles, and then ultimately template-based abstraction layers, which is going to be very important to continue the low-code theme to make it easier to incorporate all of these things in viable business applications. So let me share with you some customer examples, and we have some at an abstract level and one a little bit more details that was shared at Oracle Cloud World by our partners that I'll go into a little bit more details. But this is just a broad set of use cases we have seen around tokenization, right? This is not everything that's been done in Oracle Blockchain. There's many non-tokenization applications, and we'll schedule a session for that separately. There is also, by the way, ebook you can visit to see that on oracle.com/blockchain. Somewhere towards the top of the page, there is a link to an ebook, and we have a lot of industry vertical related content in that ebook as well. But here, focusing on tokenization, we see variety of rewards and loyalty programs using fungible tokens. We see digital currency or digital twins implications, was it CBDC that we are working on with the bank in central bank in Asia, certified supply chain tracking, where we have product tokens representing specific products, raw materials, intermediate products, and so on, linked all together. Insurance payments, monetization of company KPI data to create alternative investments. This is the one I'm going to go into a little bit more details. And then for NFTs, data marketplaces, unique products with provenance information, managing product lifecycle, such as electric vehicle batteries in the circular economy, VIP rewards. We're now beginning to see interest in healthcare insurance claims and patient records using NFT technology as well. So all of these capabilities, I think, are going to be very important going forward and will bring a lot of this technology into business applications. So here's an example of a very straightforward loyalty program built by Decathlon, which is a sports retailer around the world. In Eastern Europe, they wanted to create a loyalty program which is using tokenization to make it possible. Once you buy something in the store, you immediately, before you walk out of the store, get tokens. You can then use them to pay for lessons, game tickets, any kind of sports activities, membership in clubs and things like that. This is done cross-border, actually, so you don't have to worry about foreign exchange. This is an agriculture use case, sustainable agriculture that was done in Indonesia for palm oil production, right? And what they wanted to do is encourage farmers to provide sustainability data, but they provided capability to actually integrate an incentive rewards program. So as more sustainability information was provided to the oil mills would then fund tokens into the farmers' accounts that they could use either to purchase goods directly, for farming, or translate into actual fiat deposits into the bank accounts. This is another use case. This is a product tokenization I mentioned earlier. This is basically a company that creates specific fabrics that maintain constant body temperature, and they do it by infusing them with certain volcanic sand-derived chemical ingredients. But they don't make any of it. They oversee a large number of partners that make fibers and yarns and then fabrics and then ultimately garments from that. And this was all spreadsheet-based before introduction of blockchain, and they had a difficult time reconciling all of this data. Now this is all tracked on blockchain, and each component, as it's shipped, as it's produced, is tracked as a product token linked to its inputs and outputs, kind of applying UTXO model, but to product tokenization space, and then be able to drill down in an individual product and see what it's made of, so particular garment, which fabrics, which fibers, which, yarns, etc., and ultimately the chemical lots. And you can see company relationships, all of that derived from the data on ledger using Oracle Analytics in real time. So they can track inventory, shipments, and also collect royalty information from all of the shipments that gets accrued, and then, payments are done as well. Here's an example of luxury goods. Everledger's been a partner and customer of Oracle for a long time. They have ability to scan diamonds. There is some 40 metadata points. You can then create them, basically represent them in asset vault. And recently they've introduced NFT capability. So if you have your diamond as a retailer or even as a consumer registered in the asset vault, you can mint an NFT, and then you could use it. You can use it in the marketplace for verification of authentic ownership, or you could do exchange, you could unlock unique experiences associated with the object, and so on. So all of this kind of provenance-enriched data in an NFT associated with luxury goods. This is an insurance back office where there is different siloed systems that are used by brokers and underwriters and reinsurance companies and agents. And the payments coming in then have to be reflected across multiple silos that are not well integrated, creating a lot of manual reconciliation. They have created, as partner Supermoney, a distributed ledger, single source of truth across all of those silos, where all of the data is kept in a tokenization form and links across the multiple silos here on the single ledger, so everybody can look up the data as an authoritative source of truth. Central bank digital currencies. This is, of course, an area that's using tokenization very heavily, and we have been working with a number of banks around the world, most recently working with a bank in Asia to create an interbank wholesale CBDC solution for POC or pilot with onboarding capabilities, managing the money supply, so issuing and bonding money is actual payment transactions between financial institutions, and layered on top of that is fraud prevention and AML, CFT detection for financial regulators. So there is complete infrastructure, sandbox, starting with our permission blockchain network, and then layering on top the money system that combines both account and token or bearer capabilities in a hybrid form. And then there is analytics, currency management, and all of the other things that you need for a full CBDC implementation. A much simpler system, a partner of ours built for tokenization, using tokenization for ticketing and engagement in Italy. This is for an event that was managing attendance during Christmas holidays. They have the lights laid out on a lake, probably a couple kilometers long Christmas tree, and they wanted to control access through tokens, through tickets rather, that were issued using our tokens and verified on this platform. There is also now a company that's working on creating essentially market intelligence data from financial market insights, company insights, packages, NFTs. They have built an NFT factory that allows them to source data from various streams and databases, Oracle and files and Mongo and other things that represent company data and their own research. And those data insights and are packaged through our app builder using smart contract layer, deployed in Oracle Blockchain, and then exposed on an NFT data marketplace. So this is, again, the use of permission blockchain network in that space. And this is one that was presented at Cloud World in October that I wanted to go into a little bit more details. And it's sort of essentially a platform that's being created for trading digital and virtual assets in order to capitalize monetizable data. The idea here is that there is sort of a new generation of investors ready for full equity transition. If you combine the capabilities of cloud, computational power, blockchain as a service, all of this technology now paves the way for effective data gathering and tokenization to create and engineer data-driven investment products by taking a look at company data flows and KPIs, not looking for their stock price, but precursor data that impact the stock price, and then being able to engineer investment products based on that in order to expand investable universe, both in regulated and unregulated marketplaces, right? And we're beginning to see some openness, some cautious openness from regulators in certain countries for this. So the idea is that, as regulators begin to think about how to deal with this sort of new world, they're going to have multiple layers. It's not going to be all or nothing kind of thing, right? They're going to be regulated standard markets with security tokens that will have certain capabilities and smart contracts, basically access to utility tokens based on permission DLT. There's going to be, self-regulated cryptocurrency kind of exchanges, which is going to be outside the provenance of regulators. But there's also a gap in between, which is unregulated platforms with utility tokens and NFTs engineered to provide light investor protection and minting and burning on both permission DLT for utility tokens and then ability to transfer to open DLTs, open blockchains, if you will, for secondary trading as well. So they're building this kind of an unregulated platform, essentially to create the capability for companies to engage with investors, raise capital, and so on. This is an evolution of NFTs into more structured investment products, funds and such, using data-driven engineering of virtual assets, with compliance rules applied, and ability to also profile and do ratings on individual investors, individual market makers, and so on. So this initial release that's coming out in fourth quarter of this coming year will provide the ability to use an NFT generator factory with smart contract deployment, integration with listing and forced auction capability, and integration with secondary trading on Ethereum-based marketplaces. They've selected Oracle because of the capabilities of the cloud infrastructure being superior, faster, more reliable, low-code blockchain app builder tools and blockchain platform infrastructure. Makes it very quick and easy to create this in a matter of months rather than years. A seamless integration with a database for analytics and machine learning available in the database. Oracle Application Express low-code UI builder also helps to streamline this and provide much faster time to market. And frankly, a lot of support from Oracle as well. So we've been working closely with a partner on this. This is the architecture where you have essentially this Oracle blockchain platform linked in a network with companies' blockchain nodes, so they can basically provide the KPI data. Some companies use other data sources outside of blockchain through the REST APIs. And then there is this NFT generator factory that mints NFTs based on this company data, maybe shipments or production or climate if you're in agriculture or other things you want to be able to monetize and ultimately capitalize. And then you can use a trading platform for exchange either on Oracle blockchain or you can move it to an Ethereum-based environment using atomic NFT transfers, which I talked about earlier. And so this is a solution that will support this marketplace, if you will, for different types of investment products. And they're beginning to see strong interest in that. They're looking initially with prospecting for the companies that are going to start using this, such as retailers, creators, wine companies, etc., that want to be able to monetize their data streams and capitalize to raise funds in the market, right? So just to summarize, and we'll take some questions at the end here, we do see significant momentum in tokenization projects, but in the permission blockchain without built-in tokenization support, this used to be a problem because you had to do complex development effort and skills, frankly, were difficult to come by. So Oracle Blockchain Builder helps in 3 key ways. We enable low-code or even no-code approach to simple applications. No-code meaning you generate everything and start using it through REST APIs. Low-code allows you to customize the code that generated, add on top of it from a complex business logic. But in both cases, support for fungible and NFT tokens on Hyperledger Fabric, improving developer productivity. And the entire platform is also going to help you do this much easier and quicker. Pre-assembled blockchain as service infrastructure with everything you need to be production ready from day one. Of course, blockchain app builder for rapid development and deployment, advanced tokenization engine, which is very adaptable, starts with declarative templates. You don't need the PhD in blockchain, and various performance optimizations we've integrated into Hyperledger Fabric nodes in order to support high throughput. We're talking about high hundreds, low thousands of transactions per second kind of rates. All right, I wanted to spend a couple of minutes on how we can help you with your blockchain journey. I would just mention this book, Blockchain Revolution, from Don Tapscott, going back to 2016, but there is a phrase in there, a quote that I really think is very important. The future is not something to be predicted, but something to be achieved. We really look for people who are interested in achieving this future by getting their hands dirty and beginning to build some of these capabilities out, right? And we can work with you through a variety of ways. We can start with basic discovery to help you understand the blockchain and the needs you might have where blockchain could be a fit, understand the use cases from your industry, what might be relevant to you, do design thinking workshops where we can help design your blockchain environment and address some of the design questions, and then ultimately help you implement it. We can partner with you through our cloud engineering teams to be able to do a deep dive implementation on an MVP or minimally viable product prototype in our technical architecture workshops as well. There's a lot of materials available that if you'd like to follow up, our blogs at oracle.com/blockchain is pretty active. Here's a sample of some recent entries in there about NFT support, how to implement cross-channel updates and so on, and more coming. There is also this solution playbook I touched on earlier, which talks about how to build NFT marketplaces using Oracle Blockchain, goes into a great deal of detail. We also have a live lab. This is a hands-on sandbox where you can explore this using our low-code tools. 2 tools, a blockchain app builder, which we talked about, and Application Express, which is a low-code UI builder. you can go to this URL, or you could just search Oracle Live Labs. It will take you to this portal. Search for low-code blockchain, and there is a particular lab called Developing Low-Code Blockchain Applications Using Apex and Blockchain App Builder. You can click on that pad. It will take you to the description of the lab. Click the Start button. You can do this in a free trial environment. So you can provision a free trial tenancy and then use this lab. It takes about 2.5 hours, and there is detailed 5 steps where you're setting up the initial blockchain network. You're then using Blockchain App Builder to create, generate, deploy smart contracts. You're then creating an API gateway to link that with our Apex environment where you are deploying. This is a sample application pre-built for you to use, car marketplace, dealer marketplace, for dealers to be able to exchange cars. You can tailor it, but the starting application is there. You can install it out of the box, and then you can use the application and see the code underneath for trading cars using tokens, both fungible tokens for payment and NFT tokens for car title in this environment. So this is a car dealer network where you're funding your token account with fiat payment. Of course, it's a fake fiat payment, but it shows you how to do that. You can then register the cars on sale for the marketplace, and that creates an NFT for the title. You can search the car and buy the car. You can check the title NFT with service history. You can then do a transfer of car ownership, and then you pay for that. You settle in fungible tokens as well. So this is kind of the functionality built into the lab, and you can spend a couple hours productively to play with that. All right. More information available. Our blog, as I mentioned, videos available on YouTube, documentation. You can try the free tier. Go to our oracle.com/blockchain cloud platform, or download the enterprise version as well. If you want to connect on LinkedIn, just please mention that you've attended the webinar today. So, I know you are, coming in through the webinar. Thanks very much, everybody. Thanks for joining.